All right, so today we're going to talk about really three different topics. We're going to talk about what a probability distribution table is and the mean of the distributions, which is what helps us find an expected value. And that's what you will be asked to find on a quiz, is an expected value. It will be part of the binomial probability section on the quiz. So we will review that lesson a tiny bit today as well. All right. So a probability distribution is, well, first of all, we're going to talk about a random variable. It represents a numerical value assigned to an outcome of some kind of probability experiment. So a random variable could represent the number of tails when you flipped a coin 7 times. It could represent a number of anything, okay? There are two different types of random variables. There's discrete and continuous. I did not put this on the quiz, but let me try to help you understand the difference between the two. A discrete random variable is when something takes on a finite or countable number of possible values. In other words, you can't have decimals or fractions, basically. Okay, something that happens in whole numbers only. Number of ice cream cones sold, number of cars in the parking lot, number of people who died from something. Those are all discrete variables. A continuous random variable can take on an infinite number of possible values. Number of miles driven, you could go down to the nearest tenth of a mile, right? The time something takes, the weight something goes by, those are all things that you could break down the measurement into smaller and smaller increments, so those are continuous. So, box of cereal comes off the assembly line, that would be a continuous because they could measure it to the nearest ounce or tenth of an ounce, etc. Number of cars in school parking lot, that's going to be measured in whole numbers, so that is a discrete variable. Here's my two examples that you don't have. Time it takes to serve fast food. Anybody ever worked in fast food? Do they only go to the nearest minute? No. The little clock is counting seconds, right? So it is a that would be a continuous measurement. It's not only measured in a certain unit. It can be broken down into smaller and smaller units. Random attendance at a school board meeting. Well, if you're counting attendance, it's going to be whole number of people, so that is a discrete variable. The ones you have at the top of your page, I believe, time it takes for the classroom to move from 68 degrees to 60 degrees. Time, discrete or continuous? Can we break that down into smaller units? We could say 6 hours it took, or we could say 5 hours and 50 minutes, or we could say 5 hours, 43 minutes and 50 seconds. So that is continuous. If the second one, so the first one was continuous. I didn't write it on there yet. Sorry, I should write it down. The second one says, if I can find a mouse, it'd be really cool. Second one says number of photographs taken by a photographer at a wedding. Is that going to be a whole number, or it can be decimal or fraction? Anybody? Whole number, which makes it continuous or discrete? Would be discrete. What's happening? Why am I not getting... Come on, guys. I don't have time for this. Please don't die today. This is not... Oh, okay. We're just going to tip it sideways. Let's see if this works. Nope. Great. Nope, now maybe I got it. So this one was, oh, great. Let's try regular pen. Discrete, continuous. All right, moving on. Nope, that was totally backwards. Just kidding. This one was continuous. Wasn't paying attention to what I'm doing. Number of photos is a whole number that's discrete. Better. Okay. Again, not on the quiz. The sample space from familiar theoretical probability experiment of tossing 2 coins. Okay, we're going to toss 2 coins. They could land tails, 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 heads, heads, tails, or heads, heads. If X is a random variable for the number of heads, then X could be 0 heads, 1 heads, or 2 heads. Find the sample space in theoretical probability, okay? So we listed the choices, tails, 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 heads, heads, tails, heads, heads. So what is, so the chance of getting no heads was only tails, tails, which was 1 out of 4, okay? 1 head was either tails, heads, or heads, tails, so that happened to be 2 out of the 4, or 1/2. And then heads, heads was 1 out of the 4, so the probability of getting 2 heads was 1/4. And then they made what's called a probability distribution by listing those, and the probabilities always have to add up to 1, okay? A probability distribution of a random variable is a table, equation, or graph that links each possible value of X with its probability of occurring. These probabilities are determined theoretically or by observation. The sum of the probabilities each probability singularly must be between 0 and 1, and the sum of them all must equal 1. So we are going to, and then it says you can average the probability distribution where you multiply each value by its probability and average those. So we have this example. Do you have this one about books, guys? Okay, thank you. The number of books bought by each of 100 randomly selected bookstores customers during a week is shown. So 45 people came in and bought no books, 30 people came in and bought 1 book, 15 people came in and bought 2 books, 10 people came in and bought 3 books. So these were 100 people total. Everybody see where we got that? Then they took the frequency divided by the number of people. So 45 out of 100 people was 0.45. 30 out of 100 was 0.30, etc. They made this little table. So this is the probability, okay? Not just the frequency. To find and interpret the mean in situations, so we're going to average these. So I'm just going to talk you through this and then we'll do one together. Is that okay, guys, if we don't take time to type this one in? So I put in 0, 1, 2, 3, this in list 1, the probability in list 2, and then I did the one variable stats where I put in the list is list 1 is the number of books. The frequency list is the probability that they bought that number of books. And then I calculated the one variable stats and we're looking at the mean. The mean, when this is a frequency, okay, we multiplied and we found 0.9. What that means is on average, each customer bought 0.9 or 1 book. Okay? So the average customer who walked in, we can make a statement that says bought 1 book. All right, we're going to try it with this. The table shows the number of medical tests. You have this one, right? Somewhere? Okay. 15 randomly selected patients entering a particular hospital received each day. So this is 11, 12, 13, 14, 15 patients. They had 0 tests done, 1 test, 2 tests, 3 tests. So what we need to do is figure out the probability getting 0 tests done. So 6 out of 15 people had 0 tests done. Can somebody do 6 divided by 15? Looks like is it just 0.4? Okay. And then 1 test was done on 5 out of the 15 people, which is 0.3 repeating. Okay. And then 2 tests were performed on 3 out of the 15 people. That would reduce to 1/5, so I think it's 0.2. And then 1 out of the 15 people had 3 tests done. 1 out of 15, and that was 0.06 repeating. Okay, so then we're going to go to the calculator. And this time I'll show it, even though I have it on the screen there. So we're going to go to Stat, Enter. We're going to put in 0, 1, 2, 3 tests in list 1. Does everybody have a list 1? Anybody missing list 1? Just bring me your calculator if that's a struggle. Go over to list 2, and we have 0.4. Then I put in 1 divided by 3 here to get the 0.333, or 5 out of 15. But if you just put 0.33333 for a few places, you'll be close enough. And then 0.2, we could have typed these in instead of, we could have put 1 out of 15 or whatever it was. And then this last one, 0.0666, or it was 1 out of 15, wasn't it? So you could just type 1 divided by 15, enter, and it'll put 0.0666. As long as you got a few 6's in there, and don't forget the 0.0666. All right, then we're going to go to Stat, right arrow, 1 variable stats, but we want it to say list 1, and then for the frequency list, list 2, which is second 2. To put that number there, the L2, see the blue above the 2. If you have an older calculator, you would just type list 1, comma, list 2, okay? And the comma is above the 7. And then we're going to calculate, and we want to see this mean, which is 0.9333. Did everybody get that? Something close, depending how many. Anybody not getting that? Okay. If you were using an older calculator, let me see if I can do this real quick. You would go Stat, right arrow, 1 variable stats. It's still gonna bring it up. Yep. I can't get it to do it, but it would say 1 variable stats and then bring up a parenthesis, and then you would need to type L1, comma, L2, enter, and it would do it. I don't have the command there, so it's not going to do anything. All right. So we got 0.9333. It says, I don't care about the variance and standard deviation. I just want to interpret the mean, okay? So that part of it where it says interpret the mean right here, let me switch colors. Find and interpret the mean in the context of the problem situation. Okay, so our situation is the number of tests. So we're going to say the mean was 0.933. So the average, quote unquote, patient received or had how many tests run, guys? 0.933 would round to 1 test. Was this a hospital or a clinic or hospital? okay? So that was averaging test results, or averaging using a frequency table, which I don't think I put on the quiz. All right, binomial distribution or binomial experiment. This is what we did on Thursday last week. A binomial experiment is one which there is a fixed number of trials and every trial has two possible outcomes, either success or failure. The probability of success is the same on every single trial, and the probability of failure is always 1 minus the probability of success. The random variable x is the number of successes we want. So we used binom PDF, where the first number it wanted was it number of trials or number of successes? Can anybody pull it up? I think it's number of trials. And then probability of success. And then number of successes we wanted to have. So it's under, it's the vars key. We have to go second vars. And it's not the normal ones. You have to scroll up or down until you get to choice A, binom PDF. And it's number of trials. I did write it down correctly in the order. It's number of trials, probability of success, and then the number of successes you want to have. Okay, so let's get to a question here. There is a fancy way to write this out and do it without that button, but we used binom PDF on our calculator. And I am skipping down to question 5 on the back. We're not going to talk about this other one about healthcare fraud. Since I didn't put it on the quiz, we won't spend time doing another binomial distribution. All right. It says Mr. Hanlon distributed a 5-question multiple choice quiz to his students. There are 5 choices for each question. Ashley guesses the answer on every question. What is Ashley's probability of guessing exactly 3 questions correctly? So this would be, if you were doing this the long way, let me just, for the people who weren't here, you would do out of 5 choices, she wants to guess 3 correct. The probability of success is 1 out of 5 because there were 5 choices for each question, okay? And she wants to get 3 right. The probability of failure, anybody? 1 out of 5 is right. How many are going to be what's the probability of failure? One out of 5 are right. How many are wrong? 4 out of 5. If she wants to get 3 right, that means how many would be wrong? 2. So this is the long way of doing it. We used binom PDF. And then it was number of trials. Anybody? How many trials do we have going on here? 5 questions. Probability of success. 1 is right out of the 5 choices. And she wants to get exactly 3 right. Okay. So if we go to that binom PDF, again, it was second vars key. And scroll up or down until you find binom PDF. 5 questions. Not 55, Hofbauer. All right, probability of success was 1 out of 5, 4.2. And the number of successes was 3. She wanted to get exactly 3 right. So 0.0512, did someone else get that? Okay. Or about 5.1%. Hello?
Can you send Adriella Simmons to Student Services to leave, please?
Yes.
Thank you.
What would the probability in part A be if there were 4 choices? What would change if he made it only A, B, C, D on his quiz instead of 5 choices? Is it the number of trials that would change? The probability, yes. So it would be binom PDF, 5 questions still, but the probability of getting it right is now 1 out of 4 instead of 1 out of 5. And getting exactly 3 right still. So what's changing is the probability. So you could go back, you can go back into second vars and redo the whole question. I'm just going to change this to 1 out of 4. Did that change a lot, guys? Guessing and getting 3 right went from 5% to 8.8%. Okay? It's not a huge change. Does everybody see that? That's why most multiple choice tests, they go with 4 choices instead of 5, because it's not a huge significant change in guessing. All right, what would be the probability if it were only a true-false question? Then your chance of guessing changes a lot, right? So if we're still doing 5 questions, what's the chance that you guess correctly is a half, and what's the chance you get 3 right? It's still not a huge probability, but it's better. For you as a student, it's better. It's not better as a teacher if they can guess, but went all the way up to 31% chance that she guesses 3 out of 5 correctly. Okay? So again, it's second vars, up or down arrow till you find that binom PDF. All right, does anybody remember who was here on Friday? I don't have time to reteach the whole lesson, but what the CDF did? Jada?
It gives you, like, what the percentage that you get. If it's 3 questions correctly, it would give you the percentage that you get 0, 1, 2, or 3.
Yes, it adds the probability down. So if we said, what is the probability that she gets 3 or less correct? Then we could use binom CDF and say 5, let's just go with the true false again, and 3 or less correct. Now it's not going to give me 31 this time. Okay, it's 81% chance this time, because this is adding up the probability that she gets none right, 1 right, 2 right, or 3 right. Okay, so if we wanted more than 3 right, we could do 1 minus this probability. So just a quick review of that button. Okay, moving on to the new stuff for today is expected value. Do you have this example, guys? No? Okay, so I need you to follow real close and pay attention though, because this is the kind of question that's on the quiz. It's about a raffle ticket. It says, at a raffle, 500 tickets were sold. We are going to do some examples that are in your notes. At $1 each, where the 3 prizes are they're going to give away $100, $50, and $10. Okay, so 500 tickets sold, but everybody who bought a ticket paid $1, at least, for every ticket. Okay, $1 for every ticket. So if there's 3 prizes, what is the expected value of your net gain if you buy a ticket? Now, everybody's either going to lose their $1 or they're going to win a prize, right? But we can kind of average those out and talk about what is their expected value. So the trick to this question for most students is realizing that everybody's invested. And so even if you win $100, did you really win $100? No, because you bought a ticket for $1, okay? So the winner of the $100 really only won $99. The winner of a $50 prize really only won $49. Everybody with me here? The winner of the $10 prize won $9, and everybody else lost $1. Does that seem okay? And then we're going to multiply those by the probability, just like we just did with the probability distribution. So 1 out of 500 people wins $99. 1 out of 500 people wins $49. 1 out of 500 people wins $9. Again, that's because they had to pay for the ticket. And the other, everybody else loses $1, and it's 497 out of 500. Now, I realize this is kind of weird because it feels like it should go 1 out of 500 and then 1 out of 499 and then 1 out of 498. But we're just going to go with straight probability, 1 out of 500. Okay, that's how this works. Don't ask me why it's not different. So then they multiplied all those things and came up with about negative 0.68. What this means is the expected or average loss for everyone buying a ticket is 68 cents. Now, don't interpret that to mean that everybody loses exactly 68 cents. No one can lose exactly at 68 cents. They either lose $1 or they win something. But it is the average of everybody. All right, so let's go with, this is a different kind. You don't have this one. This one's a little bit different because it straight up tells us a water park makes $350,000 when the weather is normal, and they lose $80,000 per season when there are more bad days than normal. If the probability of having more bad weather is 35%, so the probability that they lose is 35%, what's the probability that they don't lose then, guys? 1 minus 0.35 would mean, anybody? That 65% chance that they have a good season, okay? So then we can calculate their expected profit based on that probability. Can you do that problem in your calculator real quick? So there's a 65% chance that they make 350,000. Make sure you put all the zeros in there. And then there's a 35% chance that they lose 80,000. I got 199,500. Anybody else get that? You put in the right number of zeros? Okay, so find the park's expected profit. Okay, what this basically means, guys, is if that held true, that they make 350,000 when the weather's good and lose 80,000 when it's a bad weather year, if the park did this over 100 years, they would average $199,500. It's like if the experiment was repeated a whole bunch of times, that would be the average, okay? That's kind of like, if you think about the coin toss, when you toss a coin, if you toss it 4 times, you're not going to always get exactly 2 heads and 2 tails, right? But if you did the experiment enough times, would you average out 50% heads and tails? Okay. All right, going on to this question that you do have. A resort is planning a bicycle race. The cost of sponsoring the race is $8,000. The resort expects to make $15,000 on the event. So we're going to call that profit. Okay. It's minus the cost of, it's not minus the cost. It's already taken into account. So there's a 30% chance of a hurricane arriving the day of the race. If this happens, the race will be canceled and not rescheduled. What is the resort's expected profit? Okay, this is not necessarily the kind I put on the quiz, but they will lose $8,000 because that is what they spent to sponsor the race. If there's a hurricane, what's the chance of a hurricane? 30%. They will make a profit of $15,000 cleared. We're gonna go with that because it says they make 15,000. If it's a good day and they have the race, what is the probability of that? Yes, 70%. It's 1 minus the 0.30, okay? So what does this come out? What did I do? Oh, I forgot a decimal point. I'm like, I got a really big number. Okay, sorry guys. What'd you get? Anybody? Positive? Did someone else get that? Okay, so they will make an average of $8,100 profit if this same statistic were to hold true over a bunch of years, okay? An insurance company insures a painting worth $20,000 against theft for $300 every year. The company has assessed the probability of the painting being stolen in any given year as 0.002. What is the company's expected annual profit? All right, you have to understand something about this. Everybody has to pay the company how much a year? $300, yes? Okay, so everybody pays them $300, no matter whether they have a claim or not. So if the chance they get to keep the $300 as long as it's not stolen. So 1 minus 0.002, somebody check me, but is that 0.99, I don't know why I wrote 9 there. 998. So there's a 0.998% chance, or 99.8% chance that they get to pocket the $300 for the year. But there's also a chance that they lose some money. How much would they lose though? It's not $20,000. Does anybody know what they would lose? You got the right idea. Yeah, we need to take off. It would be whatever 20,000 minus $300 is. So 19,700. Yep, I can't subtract either. So even if they end up getting the painting stolen and they have to pay the company, they don't lose a full $20,000 or pay the guy who owns the painting. Okay. So $19,700 will be lost, 0.002 chance. Okay. So 300 times 0.998, but there's a chance that they lose 19,700, but that only happens 0.002% chance. So it comes out to be a positive $260. Someone get that? Okay. If it came out negative, would the company be charging enough for their insurance? They don't want the chance to be negative, right? I mean, it's always a chance, but they would want to charge more so that their average was a positive number. Okay. This is the kind that's on the quiz. Do you have this question about the raffle, guys? Okay, so put a little star by it so you go back and look at it again before the quiz. Suppose we hold a fundraiser and sell raffle tickets. You can win a TI 35 worth 15 bucks, TI 83 worth $45, or a TI 84 color worth $100. One of each will be awarded. We sell 50 tickets, okay? So there's a 1 in 50 chance that you win the color. There's a 1 in 50 chance you win anyway, there's 3 different ones, right? 1 in 50. How many people are going to lose? How many tickets are going to be losers? 47 out of 50 losers. Everybody okay? That's the probability of losing and not winning anything. Everybody who loses lost how much money? $1. So that's a -1. Okay? But then you got to be careful. The guy who won I should have moved these a little bit closer, okay. The guy who won the $15 calculator really didn't win $15 because he paid for the ticket, so he won $14 worth of prize. Does that make sense, guys? Okay, the $45 calculator winner really only won $44 worth of prize. And the $100 calculator winner really only won $99 worth of prize because he had to pay for the ticket. All right. So you really don't need anything fancy. 1 divided by 50 times 99 plus 1 divided by 50 times 44. Don't even need the parentheses. Plus 1 divided by 50 times 14. Plus -1 times 47 over 50. I got 2.2. Did someone else get 2.2? I got a positive 2.2. So what this means to someone buying a raffle ticket is you have a good chance of coming out to the positive. Now, obviously, only 3 people are going to win. But if you are the person trying to do a fundraiser, how many dollars worth of tickets did we sell, guys? We only sold $50 worth of tickets. So you better hope somebody donated those 3 calculators, right? Because we didn't make anything if we had to pay for the calculators. That's why this came out positive. Okay, so it's a better chance that someone comes out ahead in terms of financial gain, but not in terms, you still have a 47 out of 50 chance of losing your dollar. All right, it's not a good fundraiser if we had to pay for the... All right, so your homework tonight is on 8.5a to do 11 and 12. Those are the only 2 on that page, 11 and 12, okay? And then to do the back, all of the ones that aren't already crossed off on the back. I want you also to do number 25, but I want to do this one together because you can't see the colors, okay? It says the prize wheel on a game show has 16 numbers. During one turn, a bet is made and the wheel is spun. The payoff for a $5 bet are shown. If a player bets $5, find the expected value for each. Okay, can somebody tell me what the questions are? It says green, is that the first one? Green?
Yep.
Okay. So what is the chance that you get a green? Can anybody look up here and tell? No, because the color's so bad, but this is green, so all of them that look like that one. 1, 2, 3, 4, 5, 6, 7. And how many are on there? 16 numbers. So 7/16 that you win if you get a green. Okay. So the chance you lose would be 9 out of 16. Okay. If you lose, how much do you lose, guys? What does it say we're betting? $5. So you lose $5. What does it say you win according to this table? If you bet on green, you get $10 back, but you bet 5, right? So you only clear $5. Positive. Okay, so can you do that? Seven out of 16 times 5 plus 9 out of 16 times negative 5. I got negative 0.625. Someone get that? Okay. What does choice B say? Even and red, okay? The payoff is much better, but we don't clear $25. We only clear how much? $20. And even and red are only 3 out of the 16. So the other, how many are losers? 13 out of 16 people would lose negative 5. So 3 out of 16 would clear $20, but 13 out of 16 would lose 5, negative 5. So negative 0.3125 or 31-cent average loss, that bet. I'll do E as the last one, okay? We'll just do A, B, and E. Okay, or I won't. All right, try the expected value questions and all of the questions assigned. It's just 2 on the front of the worksheet are expected value, and then there's a few things on the back, okay? It's a total of 1, 2, 3, 4, 5, 6, 7 questions. We won't count that one. We did as much as we're gonna do, okay?